Good day, everyone. Welcome to my YouTube channel. I am Sir Balati Dolfo. At this time, I will discuss to you the topic that I've been discussing for my COT2 in Science 10 in Alegria National High School. So this is prepared, of course, by me. This is Sir Jose Arbalati Dolfo, Teacher 1 from Alegria National High School. Okay, our content standards for this topic, the learners demonstrate an understanding of how gases behave based on the motion and relative distances between gas particles. Our learning competency, we have investigate the relationship between the volume and pressure at a constant temperature of a gas. We have our learning objectives are describe the relationship of the volume and pressure of the gas, then find pressure or volume given the initial and final states of gas and make calculations using Boyles Law equation. And the last one is relate the concept of Boyles Law in real life situation. Okay, those are the following objectives for. Okay, this is from Module 1, Behavior of Gases for the fourth quarter topic. So our topic for today is all about Boyle's Law. So those are the reference where I get the content of this slide to my channel. Of course, we have the materials, balloon, container, pen or thumbtacks, scissors, PowerPoint, and of course, a video. What is gas? So gas is one of the three fundamental states of matter which distinctly different properties from the liquid and solid states. A substance as oxygen or hydrogen having no fixed shape and tending to expand without limit. So those are the following definition where I got from different books regarding the definition of a gas. And the gas. Of course, first, they are easily compressed. The second, they are expand to fill their containers. They occupy far more space than the liquids or the solids from which they form. Of course, those are some of the characteristics or the properties of the gas. Okay, so this will be our motivation for this topic. The student should answer this following questions. First, what will happen to the balloon or at higher if it will be pumped with air continuously? What do you think? What will be your answer? And the second question is, why do soap bubble and blown bubble gum pop up after some time? Okay, so those are the following questions that our student will answer um, for their own understanding for this question or based on what they think regarding this question. The presentation of our lessons, of course, our lesson is being started with an activity which entitled Volume and Pressure Relationship. Divide the class into four, then let them get the activity sheets placed inside the envelope. Instructions and procedures are found in the activity sheets. Okay, so I have already a prepared activity with it contains procedures written on the sheets that I am going to distribute to the group of the students to perform the activity, and they are given 5 minutes to perform. Of course, the purpose of this activity is to let us know the necessary of the gas of the loss of gases that has something to do with the relationship of the gas volume and its pressure. So our student will be given 5 minutes to answer. Timer starts now. Okay, our student will perform the activity. Of course, I already um, set aside the activity sheets because the materials that are going to use for this activity are already listed on the activity sheets. Okay, let's continue. Continue. So we have some development of the lessons. As the volume of the container increased, what happened to the pressure exerted by the air? Then the second one, as the volume of the container decreased, what happened to the pressure exerted by the air? Then did the temperature change? So we will answer this one based on the Boyle's law that the pressure increased, the volume decreases at a constant temperature, meaning to say temperature will not change at all. Okay, so then what is the relationship of the volume and pressure of the gas? Okay, later on we will know about the relationship of the volume and the pressure of gas. Okay, as shown in the given activity, Boyle's law is an experimental gas law that describes how the pressure of the gas tends to increase as the volume of the container decreases, or can be modernly stated as the volume of the gas is inversely proportional to the pressure of the gas when temperature is held constant. So those are the answer for question number 4 earlier. Okay, let's proceed now to the next slide. Through this statement, how we can prove in Boyle's law pressure is inversely proportional to the volume and vice versa at a constant temperature. This law is an honor to the scientist named Robert Boyle. Okay, can we prove this by using mathematical problems? Yes. So let's have first the formula to be presented here. So pressure is inversely proportional to the volume, and the formula is the P1 times V1 is equal to P2 times V2. So where P1 is this initial pressure of the gas, P2 is the final pressure, V1 is the initial volume, V2 is the final volume of the gas. So those are the where we can identify what is in the formula, the variable and the formula for the Boyle's law. Okay, let's have the units used for pressure and volume. So those are the following units that some problems used to present the volume, pressure, and of course don't forget that the temperature is always being in Kelvin. The unit of our temperature should be expressed in Kelvin. So the formula to convert the degree Celsius is Kelvin is equal to degree Celsius plus 273. So this that is the way we convert degree Celsius into Kelvin. Okay, let's have now the example number 1. A sample of fluorine gas occupies a volume of 600 ml at 760 torr. Given that the temperature remains the same, calculate the pressure required to reduce its volume by 1/3. Okay, let us solve this problem so that you will be able to know the application used on the Boyle's law equation. Okay, so hope you will uh, following this example so that you will be able to answer this question. Okay, so let us present. Okay, we have our given volume 1 is equal to 600 ml. That is 600 ml. Then we have also the pressure 1 of 760 torr. So that is torr. So don't forget to write the unit. Okay, that is torr. Then we're going to find the pressure 2. So this is pressure 2 is unknown. Then we have volume 2 is 1/3 of volume 1. So 1/3 of volume 1. Okay, meaning to say 600 divided by 3. So it means that 600, that is 600 divided by 3 is equal to 200. Okay, that is 200 ml. So we are going now to use volume 2 for 200 ml. Okay, let's now proceed to the given formula. Okay, so we will erase first this one. So I hope you will follow this problem so that you can answer the question I am going to present later on. Okay, then let's now answer. Let us now use the formula for Boyles law, that is P1 times B1 is equal to P2 times V2. Okay, so we will substitute now. Our pressure 1 is 760 multiplied by volume 1, that is 600 ml. That is 600 ml is equal to pressure 2 is unknown, so we will write pressure 2. Then the volume 2 is 200 ml. Okay, 200. Okay, so to get the value of P2, we will divide 200 both sides here. Tapos we will divide both sides by 200. So this will become now 200 divided by 200. So this will be cancelled out. So we have P2 now is P2 is equal to 760 times 600 divided by 200. Okay, we have 760 times 600 is equal to 456. That is 56,000 divided by 200. So that is 200, and the answer is so we will divide this one into 200 is equal to 280. So this is now torr. So this is torr because ml is already cancelled out. Okay, so I hope you follow what I solved here. The next is, what is the relevance of knowing the concept of Boyle's Law in our daily lives? Can you give an example? Of course, Boyle's Law has a connection of what we are doing every day. For example, we have filling up a tire with air. Next, we have drawing fluid in the syringe. Then spray pens and aerosol. Then signs of breathing. So those are the example that Boyle's Law are going that Boyle's Law are being used on this example. Next is the examples or the quiz that you are going to take up. So we have two questions there for you to be able to answer in your home or anywhere you want to answer. Hope you follow the first example I presented earlier. And of course, for the assignment, you are going to study also the Charles law. That is also the uh, part of the topic, which is the gas laws. Okay, the next topic that we are going to discuss is the Charles laws. Your assignment, read Charles law in your module 2 and answer the question, how is the volume and temperature of the gas related? Okay, thank you so much for watching. Don't forget to subscribe my channel. I am Sir Jose Arbalati Tolfo. God, thank you.